Welcome to the DIY Honda Garage channel. The DTC P2A01 indicates a performance problem with the secondary heated oxygen sensor, referred to as the secondary HO2S sensor 2. This sensor plays a critical role in monitoring exhaust gases, specifically after the catalytic converter, ensuring that the emissions control system is functioning correctly. Its accurate readings affect engine performance and emissions efficiency, thereby influencing fuel economy and environmental compliance. When the sensor's output voltage falls below specified thresholds, the Powertrain Control Module, PCM, registers an anomaly and sets this DTC. The PCM utilizes the readings from the secondary HO2S to optimize fuel injection and exhaust treatment processes. Thus, addressing issues arising from this fault code is vital for both performance and compliance with emission standards. The following sections will detail the troubleshooting process for this specific DTC, as applied to the 2023 Plus Honda Accord. The DTC P2A01 signifies a malfunction related to the secondary heated oxygen sensor, specifically sensor 2, which is positioned downstream of the catalytic converter. The primary function of this sensor is to monitor the oxygen level in the exhaust gases, assisting the PCM in managing fuel injection and emissions control effectively. When the output voltage from this sensor falls below a predetermined level, the PCM interprets this as a circuit range or performance issue, triggering the fault code. This can lead to inefficient combustion, increased emissions, and potential violations of environmental regulations. Understanding the unique roles of each component involved is essential in diagnosing the issue accurately. Thus, each failure point must be investigated systematically. Several factors may contribute to the triggering of DTC P2A01. One of the most common causes is a faulty secondary heated oxygen sensor, which may not produce the correct output voltage due to internal damage or degradation. Another possible cause involves the Powertrain Control Module, which could be malfunctioning or not processing the inputs from the secondary HO2S accurately. Additionally, wiring or connector issues, such as open circuits or shorted wires, can disrupt the signal transmission between the sensor and the PCM, leading to erroneous readings. Each of these potential causes must be meticulously checked to determine the root of the problem and to ensure proper rectification. The symptoms associated with DTC P2A01 can negatively impact both vehicle performance and efficiency. A primary indicator is the illumination of the check engine light, alerting the driver to potential issues within the emission system. As the secondary HO2S fails to provide accurate readings, noticeable changes in engine performance may occur, including hesitation, reduced power, or stalling. Additionally, inefficiencies in the combustion process often lead to increased fuel consumption, adversely affecting the vehicle's overall economy. Failure to address these symptoms can also result in further complications, including damage to the engine or emissions control system, emphasizing the importance of timely diagnostics and repairs. The first troubleshooting step involves starting the engine and holding it at 3,000 RPM without a load in either the park or neutral position. This should be done until the radiator fan comes on, which signifies that the engine is warming up adequately. The next essential action is to monitor the Honda Diagnostics System, HDS, for the presence of the DTC P2A01. This step provides the technician with immediate feedback on the current status of the vehicle's emissions system and helps determine if the fault code persists under specific conditions. By conducting this initial check, one can define the next stages of the troubleshooting process with a focused approach, utilizing the data gathered. In Step 2, technicians are tasked with inspecting the secondary HO2S circuit for any potential faults. This involves checking the wiring for damage, such as frays or breaks that could disrupt the signal flow. Additionally, ensuring that all connectors are securely fastened and free from corrosion is essential, as poor connections can lead to erratic sensor readings. It's crucial to test both the SO2 and SO2SG lines, which represent the signal and ground circuits for the secondary HO2S respectively. Confirming that these wire connections are intact and functioning properly is a critical step in diagnosing the electronic system's integrity associated with DTC P2A01. Step 3 involves disconnecting both the secondary HO2S and the powertrain control module, PCM, to assess their individual conditions. This disconnection allows for specific resistance measurements to be taken across the circuit. For the secondary HO2S, ensure that the resistance is less than 1 ohm to confirm that there are no open circuit conditions. Similarly, check that the SO2 and SO2SG circuits are not shorted to ground with readings exceeding 1 megaohm. This meticulous approach ensures that the sensor and associated wiring are functioning within acceptable parameters, laying the groundwork for identifying potential faults in the system accurately. In Step 4, technicians should install a known good secondary HO2S sensor 2 in place of the suspected faulty component. This step serves to isolate the issue by providing a functioning sensor for comparison. After installation, the technician should attempt to replicate the failure condition that triggered DTC P2A01. If the symptom reappears, it points towards related components needing further inspection. Conversely, if the DTC clears or symptoms are resolved, it is confirmed that the original secondary HO2S was indeed faulty. This systematic approach ensures accurate identification of the component directly responsible for the fault code and ultimately guides the repair process. The final troubleshooting step focuses on the powertrain control module, PCM, inspection. If previous checks of the secondary HO2S and wiring have shown normal conditions, it indicates that the PCM could be the root cause of the reported issues. At this stage, ensuring that the PCM is functioning correctly is critical, as it is the brain of the vehicle's engine management system. Confirming that no internal faults exist within the PCM circuitry will determine whether a replacement is necessary. By methodically isolating components and ensuring each part works as expected, one can confidently conclude whether the PCM requires further attention or replacement. Once all repairs related to the DTC P2A01 have been conducted, it's crucial to verify the effectiveness of the work through a final repair verification process. This involves clearing the DTC with the HDS and taking the vehicle for a test drive to ensure that all systems are functioning as intended. During the drive, monitor the vehicle for changes in performance and any return of the DTC. A successful operation should not show any repeat codes, indicating that the repair addressed the underlying issue. Verification ensures accountability and provides assurance that the vehicle's emissions and engine performance issues have been resolved adequately. To prevent future occurrences of DTC P2A01, implementing a proactive maintenance regime is invaluable. Regular checks of the secondary HO2S can identify potential issues before they escalate into more significant problems, such as poor performance or increased emissions. Additionally, routinely inspecting the wiring harness for signs of wear or damage will help ensure the integrity of the electrical system connected to the sensor. Furthermore, staying updated with the latest software releases for the Engine Control Module, ECM, can prevent performance issues caused by outdated programming. These preventive measures not only contribute to optimal vehicle performance, but also extend the lifespan of key components, ensuring regulatory compliance and overall efficiency. In summary, understanding the origins of DTC P2A01 is integral to effective troubleshooting and repair. By following a structured approach that focuses on thorough inspection and testing of the secondary heated oxygen sensor, wiring, and PCM, technicians can accurately identify the fault and implement necessary fixes. Each step must be performed diligently to ensure all component failures are addressed, thereby restoring vehicle performance and emissions compliance. Additionally, adopting preventive maintenance practices can significantly reduce the likelihood of future DTC occurrences. Overall, adopting this comprehensive strategy aids in preserving vehicle efficiency and longevity, ensuring that the Honda Accord continues to operate smoothly and within emission regulations. Please like and subscribe to the channel. See you next time!